So, okay. Okay, let's solve this one. The same formula. $500 you're saying, right? Let's check. C equivalent equals to epsilon naught A D by 1 by 2A, right? The new formula I gave yesterday. Okay. So D minus T one plus T by K. Now, what are things given? T by this one. If I do this 5 by 4 mm into 1 by 2, 5 by 8 T by D, and C will be given as 100. Wait. D into D by D minus T plus T by K. LCM is correct. DD will get cancelled. T by A, D by T, 1 will be 1. Oh. 1 minus 1 by K, right? Yeah, fine. C here. So this is equals to C, which is 100 microfarad into 1, 2. And this one too. Okay. 1 minus 5 by 8. D I took as common. 1 minus 1 by 5. So solve this 5 by 8 and minus 1 by 5.7. No, I'm getting 200. See, I used the same formula. I just expanded this one in A and D. Sorry, D and D. This will get cancelled. Forget this one. Our formula was, see, let me write your formula. C equals to epsilon naught A D minus T 1 minus 1 by K. Right. Okay. So T and this T will be okay. And I just added this D and D. Okay.
Sir,
Yes.
in the second step, that 100 down one, sir, down.
Yeah. So how I got 100? That's
1
your
by
question, right?
no, sir. I'm saying 1 by 1 minus 5 by 8. Then again, you wrote 1 minus 1 by 6 or 1 by 5. That is, sir.
1 by 5. It should be 1 by 5 only. Let me check. Did I made any mistake in calculation? Formula is correct. Yes. This one. Okay. Okay. Huh. Okay, this is just simple extra calculation. Okay, no need to write this. Just to make my work easier, I did this. Even this, a rough work.
So
Yes.
I did it in a different way, sir.
Yes. What is it? Tell me.
Like I use this formula capacitance of capacitor with dielectric, like that is C dash is equal to K into C naught, sir. So here
So
the
same
question,
formula I also used.
in the question they have given the C naught value and also K no, sir. So when we multiply, we are getting 500. So
Okay. But see, why I use this formula? Because there is a difference, especially when we are using this formula. See, I gave a small note here. Where is it? Where's the formula here? Let me go there. Huh. If a space between the plate is partially filled with dielectric. So here, the it is filled with, it's partially filled with dielectric. So we are using this formula. That is for fixed dielectric. Okay, into a distance between them. So it is up like if a slab of thickness T and T is less than diameter, or sorry, distance. It is not exactly equals to distance. So this, if I show you with the diagram here, this is two plates, and it is just a plate between them. This is dielectric. Okay. So this thickness is less than distance between them. So then we have to use this formula, a direct formula, this which I wrote here. And I just manipulate this formula for my convenience. This is not the formula. I just manipulate this formula for my convenience because in that C is given. So I need epsilon naught A by D. C equals to epsilon naught A by D. So I can substitute this 100 and D is already there. And I took D common from here and here, and I divided T by D. That's why I already calculated here. So when you start this calculation, pre-calculate in your mind every time. Okay, this will do, this will do, this will do. Okay, let's try this. Yeah, by the way, you understood what I'm doing here, what I did here? Yes, no, shall I explain? Guys? Can you hear me?
Yes, sir.
Oh, okay. I thought, no, nothing. Yeah. Yes, what about this? Are you able to understand? Or shall I
Yes, sir.
explain? Adisha,
Yes, sir.
Anisha, understood this question?
Yes, sir.
Okay, Anisha,
Yes, sir.
Jafar,
So the answer will be 200, sir.
yeah.
Oh.
Okay, that is my calculation. Okay, but even in, we don't have answer here, so we cannot be sure, yes, this is the answer. But I have calculated, means I will be sure, okay, this is my answer, it will be perfect. Because I have, see, always have confidence in your answer if you have calculated perfectly. But if you want to be sure, like, you can, after the class, you can Google somewhere and tell me if it is correct or not. If it is wrong, tell me. We'll check again after the class, not now. Now we'll do some other thing now. No doubts, right? Shall we move forward?
Yes, sir.
Okay. Pravalika, no doubts?
No, sir.
ठीक है. Sai Charan?
No, sir.
Okay. What is left in this chapter? Yeah, some relations. Relation between displacement polarization. Oh, you don't require this. Okay, but still, let's study that. An electric field is not that much important, but still, let's study. Okay, as you know, standard things, electric field is applied across this thing and that thing. Like electric field E is applied across parallel plate of dielectric or with a dielectric K K. So polarization P is induced. P is equals to induced charge per unit area. Q by A. P equals to Q by A. Electric displacement D equals to epsilon naught E, which is equals to epsilon naught E plus P. Now P is equals to epsilon minus epsilon naught into E equals to K times of this epsilon naught equals to epsilon naught K minus 1 in short. So susceptibility P by E. So relation between K and susceptibility, K equals to 1 plus psi E by epsilon naught. Okay, so let's make it overall charges and all that formula so that we can do numerical properly, because I think so now we don't need much thing here. Just energy, that's it. That's it. We don't need much here. Done this writing? Everyone?
Done, sir.
Okay, let's combine those all formulas. From where we started capacitors. Okay. Okay. Yeah. Then let's combine some formulas. Well, C naught like it is presence of absence of dielectric, and there is a presence of dielectric. Parallel plate. C will be K C naught. Charge will be Q naught. It will be same. Q, it will be Q naught. Potential difference. V naught equals to Q naught. C naught, same. Q naught by C. Same. Q naught by K. Now, potential energy U equals to half CV square. So if it is U naught C naught, then it will be U will be half K C naught V naught by K whole square. So this will be equals to U naught by K. Because C and V equals to this. C equals to K C naught.
So once can you show for capacity?
Okay, shall I make a box like this? It will be better. In presence of, in absence of, simple. Or in short, we can say in when there is a battery connected, when is a battery disconnected. Oh, sorry. Whatever way you want to remember.
That's it.
This formula you already wrote, so just energy stored in capacitor. So U equals to half CV square. Other formula, C equals to Q equals CV. So we can say Q V. Other formula Q square by 2C. These three formulas are there for energy, potential energy, electric potential energy. This is most important actually. You can solve all the question. Okay, like see, generally they will give you like a combination of capacitors with resistor, they will mixed, and generally they will ask like find a charge in that capacitor or potential difference across that capacitor, then energy stored in that capacitor. So according to the given terms, you can use this formula like CV square, QV, Q squared by 2C, all this you can use according to the given terms. Wrote? And scroll. You can write, continue writing.
Sir,
Yes,
sir, yesterday you have sent one PDF, na sir.
yes.
Sir, yeah, sir, in that once explain 15th question, sir.
Think.
Yes, sir, one time.
1 second, let me open it.
Okay. Sir.
Yeah, what is there in this one? Once the see one this side is connected, then other one will be off. One other one is connected, then this will be off. Simple. When switch S turned to position 2, the percentage stored energy dissipated is, and you can calculate what will be stored energy, what will be difference in that energy. See, the question is like capacitor of 2 microfarad is charged, okay, as shown in diagram. When switch S is turned to the position 2, so percentage stored in energy, stored energy dissipate is. So what is like what is the wastage of energy? That's what we need to find out. So find out first actual, then subtract this and divide by the actual into 100.
Okay, sir.
Okay.
Okay, sir.
So first thing, you just find both difference, energy difference, divide by the actual into 100. So it will give you some percentage. So if I say T and E is common. So use first formula, C square formula. Four minus 1. No, but this way we are getting 75%, but option is D. 4 minus 1. Three by 4 is 75%. So, but option here is given as D, right?
Yes, sir.
Yeah, but if I solved it orally, I'm getting it 75. What did I miss? Okay, let me think. I'll solve this again properly.
Okay, sir.
But you try, method is same. See, you find the difference and divide by the original into 100. That is a percentage. How to find a percentage dissipated difference?
Okay, sir.
Even if it is 5 by 100. Mhm. Okay. Anyhow, I'll solve all the questions in this itself. Yeah, somebody gave something here. No, dear, I'm not writing. I was discussing with the question with him. I gave one PDF yesterday, no? So he was asking one about it. Okay, guys. Yeah, sorry for waiting. Let's do this question. Not question. Charging and discharging. So then Van der Graaf. That's it. of capacitor. Okay, charging and discharging of capacitor. So what, as we started our topic, I said one thing, right? I gave one example. What is the work of capacitor in fan? Do you remember? Anyone? Or everyone slept? Are you awake? Knock, knock.
Yes, sir.
Yeah. Okay. So what did I say that day? Like, do you remember? What is the use of capacitor in our fan?
Yes, sir.
What is it?
So when we switch on the fan, first it moves very slowly. Then it helps in storing that energy, which helps the fan to move fast.
Yeah, boost up, right? So it boosts up energy. So that like charging, immediate charging, immediate discharge, instant charge and discharge. That's the work of capacitor. That is what we are going to discuss here now. Charging and discharging of capacitor. So simple, how much time we have? Yes, we have good time, so we can do it properly. So if I write you simple words like some uncharged capacitor, connected across a source of constant. See, whenever we are writing this, imagine our fan capacitor, okay? It will be easy to understand. Constant potential difference. Such as some cell. Any cell, suppose we're charging anything, or phone, anything. Your laptop is also working on our cell, that's battery. So it takes some time to fully charge, right? Some time, like let's take some finite time. Finite time, fully charge. It takes some finite time to fully charge. Okay, let it be like, see, obviously this time interval will be very, very small actually. It will be instant actually charged, because that is actually its work. That's its work, to get instantly charged, instantly discharge. That is its work. So it will be finite time. It will be little bit amount of time. Okay. Even this time, so even in this time is it depends, like in our fan we have bigger amount, in our phones little bit small amount, depends. Yeah, that day we saw a photo, right, of the capacitors. In that also there are some big and small capacitors, if you remember. If I show you there, yeah, in this one there are some big and small capacitors, some big capacitor, some small capacitor, some bigger than that. Okay, bigger number. So this also depends upon this size of it capacitor. So the time duration depends upon that size of capacitor. It will be fraction of second, it will be millisecond, microsecond, or 1 second or 2 second, whatever, XYZ. That is not our, it's not of our business. Our topic is charging and discharging. So during charging of capacitor, few points to remember. Charge on capacitor increase from 0 to full, or let's try different way. Final steady charge. Second, potential difference across the capacitor opposes the constant potential difference of main source. These are points you already know, still we are writing. So like as charge increase, so it gives more energy. These are some common points. As we increase the charge, it can store more amount of energy. Some resistor, one capacitor, voltage source, or capacitor C, KYC. So C equals to Q naught by V naught. And what are this Q naught, V naught? So Q naught is, for C is capacity of capacitor Q naught is final charge or fully charged capacitor. Q is charge on time t, and V is potential difference across capacitor at time t. And we know I equals to dq by dt. So at time t by Kirchhoff's law, if we differentiate this one, V naught by R dq by dt minus q by c equals to 0. So dq by c V naught minus q equals to 1 by cr dt. V Kirchhoff's law R dq by dt minus q by c. Okay, fine. We apply Kirchhoff's law. Oh, but those who haven't studied current electricity, they might not know what is Kirchhoff's law. Kirchhoff's voltage law, if I let me tell you just simple, then because we are going to study this one again next chapter. Those who don't know how to apply Kirchhoff's law, for them, see, Kirchhoff's law is applied for voltage, and here we have applied KVL, means Kirchhoff's voltage law. So I'll just explain voltage law only. KCL will study later. So we will just sum all the voltage and equate to 0. That's what we did here, voltage. So in clockwise, I'm moving here. So as we are moving clockwise, if I first thing I touch here, that is positive voltage, positive side of the potential difference. So I took this as a plus. Okay. And here, and current direction is opposite to this one. Current direction we have taken here actually moves from here, higher to lower, and we have taken clockwise. So our direction and current direction is opposite. So we have taken this as negative. Same goes for this capacitors. We need voltage. So V equals to Q by C. This is the current direction, our clockwise direction. This is clockwise only, right? Yeah, clockwise direction. Even we can take anti-clockwise also, doesn't matter. It will be opposite of this one, but same thing you will get. So those who don't know, understood like what is KCL? Sorry, KVL here. Kirchhoff's voltage law. What is it? Summation of all voltage equals to 0. For time being, you just learn this much. Those who don't know. Kirchhoff's voltage law. Summation of all voltage. So here, how to make it voltage? I into R. Here, how to make it voltage? V equals to Q by C. So if we divide Q by C, we will get voltage. So I've sent it that side and dq by dt. That's what I did. Nothing big here. ठीक है. Yeah, but this is not yet over because we need Q here. So integrating. So Q equals to 0 at t equals to 0. So Q equals to CV will go there. CV naught. It will be log 1 by E to the power 1 by CRT. This thing they have not asked, but they're asking very less, rarely they're asking, but still just learn this formula. No need to go deep in derivation, it's okay. No need to remember derivation, not required. Just learn this formula, we'll apply this, that's it. Okay, we have some chemistry class now. Any doubt till now? Can you remember this formula? We'll see some special cases tomorrow, not tomorrow, Monday. We'll see some special cases. So remember the special cases, that is more than enough. Okay, done writing?
Yes, sir.
Okay, shall I stop sharing?
Yes, sir.